Okay, so here diagram shows part of velocity time graph for a particle moving at v meter per second in a straight line. So this one is it travel at a constant speed. This one decelerate, okay, until it reaches the speed of u over 2. So the total distance travel is given as 165. So find the value of u. So here for the first part we can use what we call can I squeeze in here? We can use area under the graph. Right? This is a rectangle. So for part Roman 1, your rectangle is 20 times u. 20 times u. This is a trapezium with length of sides of u and u over 2. So it's half u plus u over 2. And your height is just 10. And this area must be 165. So we can simplify this as this 3 over 2. A 3 over 2, if you cancel, is 15 over 2, right? Isn't this 15 over 2? Okay. So it's 20 plus 15 over 2. You can write 27.5, 165. Your u is 165 divided answer. U is 6. Okay, for 3 marks. No problem, right? Yeah, I'm using area under the graph for this rectangle and this trapezium. Now, find the acceleration particle between 20 and 30. Acceleration is velocity divided by the time. So my gradient will be 6 minus 3. I know if u is 6, this will be 3. Then you divide 20 minus 30. So it's basically negative 0.3. Yeah? Okay, so that's your acceleration. Now if the question says deceleration, then you put deceleration equals. Deceleration is always positive, cannot be negative. Acceleration can be negative. Acceleration simply means deceleration. Okay, now the next one. Your particle P travel in a straight line such that v is given by this. Find the speed at O. Very simple. We substitute, right? So when t equals 0, your velocity is e. Put 0 inside, minus 4 is power 3, negative 64. Okay. Find the value of t. Okay. For which particle it is instantaneously at rest. When will it be at rest? When v is what? We let v be 0, so this whole bracket here will be 0. Actually, at the power 3, I can just remove it because you cube root, what do you get? You still get 0, right? Cube root of 0 is still 0. So e power t square over 8 equals to 4. Over 8 is ln 4, logarithm form. So t square is now 8. Now ln 4, I prefer to use 2 ln 2. Right? But actually, you don't have to do this. We give him decimal, right? Can we give him decimal? Yeah?
Mistake.
I made a mistake.
No, like the I1 is e power 01.
Oh, I mean it's a 1 minus 4. Yeah, thank you. So it's negative 27. So, but this is minus 1. Tell me? Yeah. Square root 16 ln 2. Oops. Let me just change it. 3.33. Is it my answer 3.33? Yeah? Elliot, check for me. This is second. In second. Okay, finally, find the acceleration. T is 1. Actually, part B has nothing to do with part A. No unrelated question. Right? So, here, Wei Jun. This room. Okay. So, we sub in when t equals to 1. We need to differentiate this first. So when I differentiate, I bring the power over 4 t e t square over 8. Yeah? You got to differentiate. You remember how to differentiate exponential? When you differentiate e fx, you copy your e fx, differentiate the fx, put it in front. So that's what I have to do here. And I substitute t with 1. When t equals 1 minus 4, bracket square, this is 1 over 4. It's a bit long here. 3 bracket shift ln. Ln is e power 1 over 8 is 0.125 minus 4 bracket square it. Then you times with 1 over 4 times shift ln 0.125 or 1 over 8. So I got 6.98. Yeah. Okay.